Hello. We're going to go ahead and take a look at the next 3 questions over exponentials. These are all dealing with real-world application problems. Question 6, it says a business purchased a computer system for $1,500. The value of the system depreciates at a rate of 15% each year. Write an exponential function to describe the situation. So for this one, we want to make sure we start off with our initial amount, our A value. So that's our 15,000. That's what we start with. So that means we have an A value of 1,500. We also want to know our interest, that rate, which is 15%. So as a decimal, I'm going to put 0.15. All right, and those are our 2 things. And then we also need to know if it's exponential growth or decay. Because of the word depreciates, that means decay. It's losing value. So the equation for this one would be y equals that 1,500, and then it's going to be 1 minus, because it is exponential decay. I'm going to have my 15.5 to the x power, or t. The decay factor is going to be what we get when we combine the 1 and the minus 0.15, and that's going to be 0.85. And then what's the value of the system after 3 years? So here I'm going to come back to my calculator, and I'm going to go ahead and type in my function. Instead of the 1 minus 0.15, I'm just going to go ahead and put my 0.85, and I'm raising it to the 3rd power because that's how many years we're looking at. And it's going to be $921 and about 19 cents. Rounding to the 2nd decimal spot because we are talking about money. Okay. Moving on to question 7. It says the table to the right represents the growth of a culture of bacteria. Determine whether the table represents exponential growth or decay. If I look at these values, I can see they are increasing. Therefore, this is going to be an exponential growth. And it says part B is to write an exponential model for this situation. So for this one, I'm going to go ahead and use my calculator to do the lists and spreadsheets, remembering to label the X column along with the Y column. And you're going to see this on your test. It's going to be an open-ended question just like this. Okay, and we want to make sure we input all of our data. All right, press enter after every number, and I'm going to do a quick look over, make sure I have everything correct. Then we got to do Control Doc to add a calculator, and then it's menu, statistics, which is option 6. Then we're going to go to option 1 for stat calc, and then I'm going to go all the way down to option A for exponential regression. We're going to input the X for the X list, Y for the Y list, and I get my values. So this one is going to be kind of like your test. We see our R squared value is not equal to 1. That's okay. That sometimes happens when you have this real world data. It's not always going to be perfect, and that's okay. So here I'm going to go with what I have. If you want to try and do menu 2 to try and get a fraction, you can. We can see they're still not nice. I'm going to go ahead and go back to the decimal form. Okay, so here it will be my A value. Okay, so that's going to be, I'm going to go ahead and round to my whole number. So that's going to be about 400. And then my B value, I don't need to worry about the 1 plus or the 1 minus because it's already all there for me. And I can also confirm this is indeed exponential growth because this B value is greater than 1. And actually, I'll go ahead and round to the 3rd decimal spot. Okay. It says, using your equation to predict the number of bacteria there will be after 24 hours. So this, I don't need to retype it. I can go ahead and open up a graphing page. And when I arrow up, my information is already transferred over. I just need to click enter. And then I can go Control T, and I can go down for when my X value is 24. In 24 hours, I get my value, and it is okay, 25,519. And I round it to the whole number because we're talking about bacteria. Discrete. Okay, going on to question 8, determine whether this is exponential growth or decay. Because this is greater than 1, it is growth. Identify the start amount. The start is our A value, so that's going to be 15. And then find the number of people infected with the virus after 11 days. So I'm going to go to my calculator screen here. I have my equation, so I'm going to go ahead and type it in. This would be 15, 2.3, and I'm going to raise it to the 11th because that T is representing our time in days. And after 11 days, we have, where we started off with 15 people infected, we are now up to, that's a large number. Did I type it in right? Yep. That's a lot of people. I hope this virus isn't too bad. Okay, so we're at 142,921 people. And since we are talking about people, once again, I round it to my nearest whole number.